Our next problem is a uniform rod of mass 20 kg and length 5 meter leans against a smooth vertical wall, making an angle 60 degrees with it. The other end rests on a rough horizontal floor. The friction force that the floor exerts on the rod is, take Z is equal to 10 meter per second square. So here a rod is made like that, it is leaning on a wall, a vertical wall, like this, whose length is 5 meter, this is 5 meters, whose mass is 20 kg, so which is acting at the center. If you consider the central force, it is acting downwards with weight mg, and it is balanced, like it is not slipping on the floor. So why? Because there is a force acting, frictional force is acting on the edge which is touching the floor. Because of that frictional force, it is not slipping. So we need to find out that frictional force here. And here rod is making, with the vertical, rod is making 60 degrees angle. That's what is given. And any other things, right? So here rod is not moving. So first of all, take the free body diagram. So here a normal force of this vertical thing is acting. So normal force of wall acting in this direction, and mg acting downwards, and the normal force of the floor, is acting upwards, and the frictional force is acting towards this wall, like this. So now using the free body diagram, we need to equate the vertical forces. So here vertical forces are NF acting opposite to mg, so NF is equal to mg, and NW, normal force with the wall, is same as frictional force F. So these are the things that we got from the picture. And if the rod is at rest, so if you take any point and around it, if you take the circular forces or torques which are acting on it, which is making that object not to move, so we need to take any other point. Like for example, if we take here, because I have two forces acting here, those will be cancelled out while taking the torques. So I will take here, consider it as O. So from here, what are the forces acting for this rotation? Okay, rotation is not there, for we will consider the clockwise and anti-clockwise torques here. So here, because of NW, it is acting anti-clockwise, because of mg it is acting clockwise. So if you equate that one, we will get the relation. So here consider this force NW, so the perpendicular distance from that is, so here it is 30 degrees, NW, and the distance, perpendicular distance from the O will be this much. This much will be given like sine 30 opposite by hypotenuse. So it is hypotenuse, that is 5 into sine 30, which should be equal to, because anti-clockwise torques are equated to clockwise torques. So here this is clockwise torque, that is mg, and the perpendicular distance is this much. So here it is 60, and here also it will be 60. So for this it is opposite, so we can take a sine 60 with a hypotenuse 5 by 2. So this is what the relation from the torques. Now NW is F, so F is equal to, we need to find out F only, so bring this to that side, which is equal to M is 20 kg, G is 10, sine 60 is root 3 by 2 into 5 by 2 divided by 5 into sine 30 is 1 by 2. This is 5 by 2 cancelled out with this 5 by 2. 2 1s are, 2 10s are, so this is 100 root 3. So answer is third one. So the thing is, we need to draw the free body diagram, equate or sum up those oppositely acting forces, and from that I am taking anti-clockwise torques is equal to clockwise torques, because the object is not rotating or slipping at all. So from that relation we got the answer.